Benjamin Holt had a problem. His steam tractors kept sinking. The San Joaquin Valley had some of the richest farmland in America, but the soil was so soft that any heavy machine sank up to its axles. Other engineers gave up. Holt didn't. He took the wheels off and replaced them with something no one had tried before: continuous tracks, like a tank, a belt of linked plates spreading weight across the ground. They called it the Caterpillar. Competitors laughed. And then it changed farming, construction, and warfare permanently. This is the story of a machine that shouldn't have worked, built by a man who refused to accept failure, tested in soil so soft that horses couldn't walk through it. And by the time the world stopped laughing, this strange contraption from a California factory had helped win a war, build an aqueduct, and transform every industry that moves dirt for a living. But before we get to the trenches of France or the desert of the Mojave, we need to understand why Benjamin Holt was so desperate. We need to understand the problem that drove him to rip the wheels off a perfectly good steam tractor and try something that over 100 inventors before him had failed to make work. We need to talk about peat. If you've never worked in the Sacramento-San Joaquin Delta, you probably don't understand what peat soil actually is. Most people hear soft ground and imagine mud. They imagine wet dirt that squishes under your boots. That's not what we're talking about here. Peat is the accumulated remains of dead plants, compressed layers of organic material built up over thousands of years underwater. The Sacramento-San Joaquin Delta was once a vast wetland, covering hundreds of thousands of acres, where the Sacramento and San Joaquin rivers met before flowing into San Francisco Bay. The peat beneath it formed when the region was marsh. Tule reeds and sedges died and sank, decade after decade, century after century, until the ground itself was made of their remains. Some of that peat was over 40 feet deep, 40 feet of compressed plant material, laid down over 4,000 years. When the farmers came in the 1850s following the Swamp and Overflowed Lands Act, they saw opportunity. They built levees from mounds of mud to keep the water out. They drained the wetlands. They created what they called islands, though these weren't islands at all. They were reclaimed marshland, surrounded by levees, pumped dry, and opened for agriculture. And the peat delivered. The soil was so loaded with organic matter that crops practically exploded out of it. Potatoes, onions, wheat, barley. Land that cost $1.25 an acre when reclaimed sold for $30 an acre within a year. By 1870, that same land fetched $75 an acre. The Delta became an agricultural gold mine. But there was a problem, a serious problem that nobody fully understood at first. The peat was light, spongy, full of air pockets where water had once been. And when you drained it, when you exposed it to oxygen, something terrible began to happen. The organic material started to decompose. Microbes woke up and began eating the peat, converting it to carbon dioxide, releasing it into the atmosphere. The ground itself began to shrink. And that ground, even before it started disappearing, couldn't support weight. A man walking through a delta field would sink to his knees. A horse pulling a plow would sink to its belly. The farmers tried everything. They strapped wooden boards called tule shoes to their horses' hooves to spread the weight. It helped, but not enough. They needed mechanical power. They needed tractors. But when you put a 50,000-pound steam tractor on that ground, the machine simply disappeared. Imagine watching your investment, your pride, your livelihood, sink slowly into the earth while you stand there helpless. Imagine the sound of the engine still running as the wheels spin uselessly, burying themselves deeper with every rotation. The harder you try to power out, the deeper you sink. Imagine knowing that the soil beneath your feet contains enough organic matter to grow anything, but you can't work it because every machine you own gets swallowed whole. This wasn't just frustrating, it was economically devastating. The Delta had some of the most valuable farmland in California, but farmers couldn't use modern equipment on it. They were stuck in the animal power age, while the rest of agriculture mechanized. The cost of extraction when a tractor did get stuck could exceed the machine's original purchase price. That was the reality facing farmers in the Delta at the turn of the 20th century. And that was the problem that landed on Benjamin Holt's desk. Now, Benjamin Holt wasn't born in California. He came into the world on January 1st, 1849, in Concord, New Hampshire, the youngest of 4 brothers and 11 siblings total. His father, William Knox Holt, owned a sawmill that produced hardwood for wagon and coach construction. Young Benjamin grew up surrounded by machinery, surrounded by the sounds of saws and the smell of sawdust, watching his father solve mechanical problems day after day. He learned what made things work and what made them fail. He learned that problems were just puzzles that hadn't been solved yet. And he learned the value of persistence, of trying again when the first attempt failed, of examining failure not as defeat, but as information. In 1864, Benjamin's older brother Charles arrived in San Francisco and founded C.H. Holt and Company, manufacturing wooden wheels for wagons. The brothers William Harrison and Ames Frank followed in 1871. By 1883, Benjamin had joined them, following his brothers west to California after both his parents had passed. Together with Charles, Benjamin founded the Stockton Wheel Company, investing $65,000 in factory equipment. They employed 25 skilled workers across 2 facilities. The company quickly gained recognition for superior wood treatment processes, producing wheels that lasted longer than their competitors. But Benjamin was restless. He spent hours in his personal workshop, tinkering, experimenting, pursuing ideas that caught his imagination. He was fascinated by the innovative machines of his day. He rode in automobiles, airplanes, even a Zeppelin. He owned over 45 different patents by the time he died. Everyone in Stockton called him Uncle Ben. The Holts saw opportunity in the agricultural machinery market. In 1886, they began producing combine harvesters. By 1890, they had moved into steam traction engines. The company was renamed Holt Manufacturing Company in 1892, with Benjamin Holt as president. Their first steam tractor was a monster, 24 feet long, weighing 48,000 pounds. A single cylinder developed 40 to 70 horsepower, depending on the steam pressure. The drive wheels were powered from a countershaft by massive link chains. The machine could haul 50 short tons of freight at 3 miles per hour. Up to this point in America, animal power moved goods. Horses and mules pulled wagons and plows. The steam tractor was a revolution, replacing 50 animals with one machine. The Holts sold their tractors to farmers across California's Central Valley, building a reputation for quality and innovation. But monsters sink. The Delta Peat swallowed Holt's machines just like it swallowed everyone else's. Farmers who had purchased expensive steam tractors watched them bury themselves in fields that promised agricultural fortunes. The machines that were supposed to increase productivity were instead becoming liabilities. And Benjamin Holt wasn't the kind of man who accepted defeat. His first attempt at a solution was logical, if impractical. If the problem was weight distribution, why not spread the weight over a larger area? The mathematics were simple. Reduce pressure per square inch by increasing the number of square inches contacting the ground. Holt's engineers added more wheels. They made the wheels wider. They mounted 3 massive drive wheels on each side, each one 6 feet wide and 7.5 feet tall. The result was a machine that measured 45 feet across, with 18 feet of drive wheels sticking out on each side of the engine. The single front steering wheel was replaced with a 10-foot wide wooden barrel to keep the front end from sinking. The monster had become a behemoth. It didn't work. The machine was too unwieldy to maneuver. It couldn't go through gates, which made moving between fields impossible without tearing down fences. It couldn't cross bridges, which meant entire road networks were off limits. It couldn't turn around at the end of a field without a turning radius measured in acres. And despite all those enormous wheels, it still got stuck in the peat. The weight was still concentrated on the axles. The wheels still cut down into the soft ground. The only difference was that now, when it got stuck, you had an even bigger machine to extract. Getting one of those things unstuck required teams of horses, block and tackle systems, hours of labor, and expense that exceeded any profit the machine could generate. The solution had become its own problem. Holt needed a different approach, and in 1903, he traveled to England to find it. You see, Benjamin Holt knew that other inventors had been working on the same problem. Over 100 patents for crawler-type tractor treads had already been issued around the world by 1903. The concept of a continuous track, an endless loop of plates that would pick up and lay down its own road as the machine traveled, had been around for centuries. Leonardo da Vinci had sketched something similar in his notebooks. Various inventors in England, France, and America had built prototypes. The idea was brilliant. Instead of wheels that concentrated weight on a small contact patch, you'd have a track that spread weight across a large surface area. Instead of pushing down into soft ground, the machine would essentially roll on its own portable road. The track would be picked up at the rear, carried over the top, and laid down again at the front. But none of these machines worked in the field. The hub of innovation was in England. A company called Hornsby had been developing track-type machines since the early 1900s. They'd even demonstrated a tracked tractor to the British Army in 1909, which awarded them a prize for the concept. But the Army didn't pursue it. The machine wasn't practical enough for real-world use. Holt went to England to learn. He visited the manufacturers. He watched their demonstrations. He studied their designs, examining the linkages, the track materials, the drive mechanisms, and he watched them fail. The tracks broke under load. The linkages seized when dirt got into the joints. The mechanisms couldn't handle the stresses of actual field work. The materials weren't strong enough. The engineering wasn't robust enough. Every machine he saw in England fell apart when subjected to real conditions for more than a few hours. Benjamin Holt returned to Stockton with knowledge, but no solution. He'd seen what didn't work. He understood the challenges better than before, but he still couldn't make a continuous track survive actual use. Then, he did what true inventors do. He stopped looking for someone else's answer and started creating his own. Holt had something the English engineers lacked. He had the metallurgical capabilities of his own manufacturing company. He had machinists and pattern makers who had spent decades building farm equipment. He had a factory that could produce its own parts, test them, modify them, and produce improved versions within days. And he had an intimate understanding of the specific conditions where his machines needed to work. The peat soil of the Delta wasn't like the mud in England. It wasn't like anything else in the world. It required a specific solution designed for specific conditions. Not a theoretical machine that might work anywhere, but a practical machine that would definitely work here. Benjamin Holt didn't work like most engineers. He didn't create complete design layouts or detailed drawings. He had a little shop across from the main office building in Stockton, equipped with machine tools and a pattern shop, where half a dozen people worked solely for him. He would describe what he wanted to his pattern makers and machinists, sketching rough ideas, explaining his vision, and they would build it. His nephew Pliny later recalled that Uncle Ben did his inventing alone, working from ideas in his head that he conveyed directly to the craftsmen who worked for him. It was old-school engineering, hands-on and iterative, built on intuition refined by decades of experience. Holt instructed his mechanics to take one of his existing steam tractors, a machine designated number 77, and remove the rear wheels. In their place, they would install a pair of tracks that Holt had designed using his company's metallurgical capabilities to create chain links that could survive real-world conditions. The tracks were made of wooden slats, 2 by 4 inches, bolted to endless link chains. Each track was 9 feet long and 2 feet wide. Sprockets mounted on the axle would drive the chains, and rollers would ride on top of the lower loop, supporting the machine's weight. The design spread approximately 18,000 pounds across a contact area of 36 square feet, instead of concentrating it on wheel rims a few inches wide. The whole contraption looked absurd. Nothing like the elegant machines that worked on paper. Nothing like the sophisticated designs he'd seen in England. Just wooden boards bolted to chains, driven by sprockets, guided by simple rollers. Industry experts said it would never work. Competitors shook their heads and waited for Holt to embarrass himself. The concept was too crude, the materials too ordinary. Everyone knew that tracks broke, that chains failed, that this approach had been tried 100 times before. On November 24, 1904, Thanksgiving Day, Benjamin Holt and his team transported number 77 to the edge of Mormon Slough, just outside Stockton. The peat field beyond the road was a death trap for conventional machines. A man couldn't walk through it without sinking to his knees. Horses couldn't be used at all. Existing tractors had tried to cross similar ground and been swallowed up to their boilers. And yet, this was exactly the kind of ground that farmers needed to cultivate. This was the land that promised agricultural fortunes if only it could be worked. Holt's mechanics removed the wheels from number 77 and installed the new track units. The 40-horsepower machine now looked like nothing anyone had ever seen before. It was part tractor, part mobile railroad, part mechanical insect. Benjamin Holt climbed aboard. His assistant stood watching. The November air was cool. The peat stretched out ahead, dark and soft and deadly to machines. The engine fired. Steam built pressure. The tracks began to turn, and number 77 moved forward into the peat. The machine didn't sink. It rolled across ground so soft that walking through it was impossible. The wooden slats laid down a road. The rollers carried the weight. The chains picked up the slats and brought them around for another pass. The pressure per square inch was low enough that the peat held. They hooked up plows and ran a proper test. Number 77 pulled 4 gangs of plows 2 inches deeper than a wheeled Holt 60-horsepower model could pull 3 similar gangs. The tracks left barely a perceptible impression in the soil. Where the wheeled machines would have buried themselves in minutes, the crawler worked steadily for hours. The test was a complete success. Farm Implement News would later report that in a tract where a man could not walk without sinking to his knees, and where tool-shoed horses could not be used, the new track-type tractor was operated without a perceptible impression in the ground. Land that had been useless for crop raising for years, because no way was found to plow it, had been brought back into production. Benjamin Holt had solved the problem that had defeated over 100 inventors before him. The machine, number 77, was sent to the Holt Ranch on Roberts Island in the Delta, where it operated steadily for an entire winter, proving that the success wasn't a fluke. It worked day after day, in conditions that had swallowed every wheeled machine ever tried. But here's the thing about inventions. Building something that works is only half the battle. The other half is convincing the world that your strange contraption isn't just luck. Holt improved the design and tested it again in March 1905. This time, he brought the company photographer, a man named Charles Clements, out to the field to document the machine in action. Benjamin and his nephew Pliny accompanied Clements, watching as number 77 crawled across the soft ground. Clements set up his camera. He looked through the lens at the upside-down image that cameras produce. He watched the tracks rolling over the carrier rollers, rising and falling in an undulating motion as the machine moved forward. And he made an observation that would stick with the machine for over a century. "If that don't look like a monster caterpillar," Clement said. Some accounts say Benjamin Holt didn't like the name at first. It seemed undignified, too casual for a serious piece of industrial machinery. The company tried other names for a while. They called the machines mud turtles and paddle wheels and platform engines and treadmill tractors. Official documents from those years use various terms. None of those names caught on. But Caterpillar did. Holt's nephew Pliny and other family members eventually convinced Benjamin that Caterpillar was the logical choice. It was memorable. It captured something essential about the machine, the way it moved, the undulating motion of the tracks. It was the kind of name that would stick in people's minds. By 1908, the Stockton Press recognized what Holt had created. The Daily Evening Record reported that the Caterpillar will without question become the greatest advertisement that Stockton has ever had for achievement in mechanics, not accepting the combined harvester, for the new tractor engine will be used in all parts of the world, in the tropics and in the frozen north, and every one of them will bear the label of Stockton manufacture. By 1909, the name appeared on the tractors themselves. In August 1910, Holt registered Caterpillar as a trademark with the United States Patent Office. And the world started paying attention. If you're still watching, hit subscribe. We're about to get to the war. Between Thanksgiving 1904 and the end of 1906, Holt's team built and tested 6 more track-type tractors, refining the design with each iteration. In 1906, the company sold its first steam-powered crawler commercially. In 1908, they produced their first gasoline-powered Caterpillars, using engines made by a newly formed Aurora Engine Company division. The gasoline engines offered advantages over steam. They didn't require constant water and fuel. They started faster. They were more efficient for the agricultural market. By 1908, Holt was selling both steam and gasoline crawlers, adapting his technology for different applications. But here's what really proved the technology. Here's what made skeptics into believers and turned a strange California invention into a global phenomenon. The Los Angeles Aqueduct. In 1908, Los Angeles was growing faster than its water supply could sustain. The city needed to bring water from the Owens River, over 230 miles away, across the Mojave Desert and through the Tehachapi Mountains. The project would be one of the greatest engineering achievements of the era, designed and supervised by Chief Engineer William Mulholland. But Mulholland had a problem that seemed insurmountable. Materials needed to be hauled from railroad stations out to construction sites scattered across the desert. The terrain was brutal. Deep sand that swallowed wagon wheels, steep grades that exhausted animal teams, waterless wastelands stretching for miles where horses and mules would die of dehydration. Horse and mule teams could do the hauling, but the cost was astronomical, 40 to 80 cents per ton per mile. For a project that would require moving hundreds of thousands of tons of material, animal hauling would break the budget before construction was half finished. Someone mentioned they'd heard about a machine made in Stockton, something called a Caterpillar, that could cross soft ground without sinking. Benjamin Holt sent a young man named Paul Weston to the desert with a steam-powered Caterpillar for the first trial. Weston would later recall that he was the boy who was sent down there by Ben Holt to demonstrate the new and revolutionary Holt Caterpillar traction engine to the Los Angeles Aqueduct engineers as they sought a way to cut the horse and mule freighting bids of 40 cents a ton mile. The engineers were skeptical. They had seen machines fail in conditions far less demanding than this. The Mojave Desert was not the soft peat of the Delta. It was hard-packed sand and loose rock, and grades that climbed 10, 15, 20%. The Caterpillar didn't fail. It hauled loads weighing up to 50 tons across deep sand. It climbed grades of 10 to 30% without breaking down. It traveled at 4 miles per hour through terrain that would have killed horses. And the cost dropped to 20 cents per mile, half of what horses charged at the low end, a quarter of what they charged at the high end. William Mulholland ordered 25 more Caterpillar tractors and 78 specially designed Holt wagons. Paul Weston spent 2 years living at the Harvey House in Mojave, delivering and maintaining the 28 Holt tractors that followed that first demonstration. He watched the Caterpillars haul equipment and materials up impossible grades, across waterless stretches, to construction sites scattered across the desert. Over the 5 years of construction, 27 of the first 100 Holt Caterpillars ever built went to work on the Los Angeles Aqueduct project. They hauled rock, cement, supplies, and machinery from the railroad to the construction sites. One report from a single section showed that 14 Caterpillar tractors hauled materials a total of over 26,000 miles at an average cost of 20 cents per mile. But the desert was a demanding classroom. The machines broke down in ways they never had in the Delta. Mechanical problems emerged under the brutal conditions of desert heat and sand and constant heavy hauling. And because the aqueduct had contract deadlines, Holt's engineers had to find solutions fast. The result was a stream of improvements that transformed the crude 1904 prototype into a robust industrial machine. All-steel construction replaced the wooden track slats. 3-speed transmissions provided better control over power delivery. Better spring suspension systems absorbed shocks that had broken earlier machines. Improved clutches lasted longer under heavy loads. Every part that failed was strengthened for the next generation. The Los Angeles Aqueduct project didn't just prove that Caterpillars worked. It forced them to get better. Every breakdown was a lesson. Every repair was an improvement. The machines that emerged from that desert crucible were fundamentally different from the machines that went in. The aqueduct was completed in 1913. It brought water to Los Angeles, enabling the city to grow into the metropolis it is today. And it made William Mulholland so famous that the city named a drive after him. But it also made Caterpillar a household name. The machines that conquered the Mojave attracted attention from engineers working on other impossible projects: road construction, mining, logging, heavy hauling in conditions where conventional equipment failed. And then came the war. It's 1914. The assassination of Archduke Franz Ferdinand has set off a chain reaction that draws nation after nation into conflict. Within months, the war of movement that military planners expected has become something else entirely. The Western Front has solidified into 2 lines of trenches stretching from the Swiss border to the English Channel. Hundreds of miles of fortifications, barbed wire entanglements, machine gun nests, and artillery positions. Men live in holes in the ground, knee-deep in mud, while shells fall around them day and night. Any attempt to advance means crossing no man's land. Open ground, cratered by explosives, swept by machine gun fire. Barbed wire tangles that stop infantry cold, while machine gunners cut them down. Thousands of men die in minutes during frontal assaults that gain nothing. The generals need a solution. A way to break through the trenches. A machine that can cross the shell-torn terrain, resist machine gun fire, and provide mobile firepower to support the infantry. But the mud, the endless mud of Flanders and France, swallows everything. Horses die by the thousands. Wheeled vehicles sink to their axles. Artillery pieces disappear into shell craters. The very ground has become an enemy. And then a letter arrives on the desk of a British Army officer named Ernest Dunlop Swinton. The letter is from an old friend, a mining engineer named Hugh F. Marriott, whom Swinton had met in South Africa. Marriott had traveled to Antwerp and seen an American machine on demonstration. He thought it might be useful for hauling artillery. "I have just seen a Yankee machine they call a Holt Caterpillar tractor," Marriott wrote. "This machine climbs like hell." Swinton passed the information along to various military and political figures, but with no war on the horizon, the idea seemed to be nothing more than a matter of transport efficiency. Then came August 1914. Then came the trenches. On October 19, 1914, while driving a car in France after witnessing the carnage at Ypres, Ernest Swinton had a revelation. He had seen how machine guns massacred infantry attacking across open ground. He had seen how the mud swallowed everything. And he remembered that letter about the American machine that climbed like hell. What if you took one of those Caterpillar tractors and built an armored fighting vehicle on top of it? What if you made it bulletproof, mounted machine guns or artillery, and sent it rolling across no man's land? The tracks would cross the cratered terrain. The armor would stop machine gun bullets. The mounted weapons would suppress enemy positions. Swinton prepared a specification: a gasoline engine, a speed of about 4 miles per hour, the ability to cross trenches up to 4 feet wide, armor-proof against machine gun fire, mounted weapons to engage the enemy, all of it built on a Caterpillar tractor chassis. He began advocating for what he called a machine gun destroyer. He sent proposals to his superiors. They weren't interested. Minister of War Herbert Kitchener was a traditional soldier who saw no place for mechanical contraptions in warfare. The War Office viewed Holt tractors as useful for hauling artillery to the front lines, but not as fighting vehicles. The idea of armored machines seemed fanciful, impractical, a waste of resources better spent on proven methods. But Swinton's idea found one powerful advocate who had the vision to see what others missed: Winston Churchill. At the time, Churchill served as First Lord of the Admiralty. He wasn't supposed to be involved in land warfare at all. But he saw something in Swinton's proposal that the Army men missed. He saw the possibility of breaking the stalemate, of saving lives by providing protection for attacking troops, of mechanizing warfare in a way that would change everything. Churchill authorized £70,000 in Admiralty funds to develop what they called land ships. The project was technically outside his authority. He funded it anyway, believing that the potential reward justified the bureaucratic risk. The name tank came later, a code word to disguise the true nature of the project on shipping documents. Workers building the machines were told they were constructing water tanks for Mesopotamia. The cargo was listed as water tanks. The deception stuck, and the name became permanent. The British tanks that emerged from this program weren't direct copies of Holt tractors. Engineers William Tritton and Walter Gordon Wilson designed the machines independently, creating the rhomboid-shaped Mark I that would become iconic. But they used the same fundamental principle that Benjamin Holt had proven in a California peat field 11 years earlier: continuous tracks, spreading weight across a large surface area, allowing heavy machines to cross terrain that would swallow wheels. And while British engineers developed their tanks, Holt Caterpillars themselves went to war. By 1914, shortly after war broke out, British and French forces began purchasing Holt tractors in large quantities. They used them to haul artillery pieces to the front lines, replacing horses that kept dying in the mud. They used them to move supplies across terrain that defeated conventional vehicles. They used them because they worked where nothing else did. By 1916, approximately 1,000 Holt tractors were serving with the British forces alone. The machines weighed about 18,000 pounds and had 120 horsepower. They pulled howitzers. They dragged ammunition wagons. They hauled wounded men to aid stations. They operated in mud so deep that horses drowned in it. The Quartermaster Corps used them to haul long trains of freight wagons over the unimproved dirt tracks behind the front lines. Where roads existed, wheeled vehicles could operate. Where roads had been destroyed by shell fire, only the Caterpillars kept moving. By the time the armistice was signed in November 1918, 10,000 Holt vehicles had served in the Allied war effort. On April 22, 1918, General Ernest Swinton traveled to Stockton, California. The The people of Stockton held a huge parade in his honor. At a public meeting, Swinton stood next to Benjamin Holt and addressed the assembled workers. The man who had conceived of the tank standing next to the man who had invented the tracks that made it possible. "It was the Caterpillar track-type tractor," Swinton told the crowd, "which inspired my idea and helped change the course of the war." Benjamin Holt was recognized by the general for his contribution to the Allied war effort. Britain's gratitude was delivered personally by the man who had transformed a letter about a Yankee machine into the first armored fighting vehicles in history. Tanks had profoundly altered ground warfare tactics. They had helped break the trench stalemate. They had saved countless lives by providing mobile cover for attacking infantry. And they had proven that the principle Benjamin Holt demonstrated on Thanksgiving Day, 1904, could change the world. If you made it this far, hit subscribe. There's more to this story, and it gets complicated. Because the war that made Holt famous also nearly destroyed his company. During World War I, Holt Manufacturing operated at full capacity building machines for the military. Government contracts poured in. The company expanded its facilities. By 1917, total company assets had increased by more than $12 million. They earned over $23 million in government contracts alone. But when the armistice came in November 1918, those contracts evaporated overnight. Suddenly, Holt was left with huge surplus inventories of heavy-duty tractors designed for military use. These machines were too big, too expensive, and too powerful for ordinary farmers. The agricultural market had been dominated during the war years by Holt's primary competitor, C.L. Best Gas Traction Company, which had focused on smaller, more practical farm tractors, while Holt chased military contracts. C.L. Best was the son of Daniel Best, who had sold his company to Holt back in 1908. The younger Best had worked for Holt briefly, then left in 1910 to form his own company. He was an engineering mastermind, and his machines earned him the nickname the Henry Ford of the track-type tractor. While Holt built machines for the war, Best built machines for farmers. When the war ended, Best had the market, and Holt had the inventory. The company tried to pivot. They focused on heavy construction equipment. They sought to capitalize on the Federal Aid Highway Act of 1921, which funded a $1 billion federal highway building program. America was about to pave itself, and Caterpillars were perfect for road construction. But the conversion was expensive, and Holt was already carrying debt from the wartime expansion. The factories needed retooling. The sales force needed retraining. The product line needed redesigning. And then came the Depression of 1920 to 1921. Sales dropped across the industry. Both Holt and Best struggled. Product lines overlapped, with both companies making similar machines for the same markets. And the legal battles continued. You see, Holt and Best had been fighting each other in court since 1905. Patent infringement suits, trademark disputes, contract violations. Both companies employed expensive lawyers to attack the other, year after year, lawsuit after lawsuit. By 1925, the two companies had spent approximately $1.5 million in legal fees fighting each other. That's the equivalent of over $27 million today. Burned in courtrooms instead of invested in factories. It couldn't continue. Benjamin Holt had pushed himself hard for too long. The war years had taken their toll. The stress of running a company through explosive growth and sudden contraction had worn him down. On December 5, 1920, at the age of 71, Benjamin Holt died. He never saw what became of his company, but his legacy was already secure. Over 45 patents bore his name. The tracked tractor he had invented had transformed agriculture, construction, and warfare. The name Caterpillar had become synonymous with machines that could go anywhere and do anything. After Holt's death, the financial pressures continued. Both Holt Manufacturing and C.L. Best struggled through the early 1920s. The Depression lingered. The legal battles drained resources that neither company could afford to lose. Both companies streamlined their overlapping product lines, trying to cut costs. Harry H. Fair, a bond broker who had helped finance C.L. Best's debt, saw what needed to happen. He He recommended that the two companies should merge, stop fighting, combine resources, create a single company strong enough to dominate the market. Finally, in April and May 1925, the inevitable happened. The financially stronger CL Best merged with the market leader Holt Manufacturing. The new entity needed a name. They considered various options, but they chose the one that everyone already knew, the one that had become synonymous with tracked machines, the one that soldiers in France had depended on when nothing else worked. Caterpillar Tractor Company. C.L. Best himself, the man who had been Benjamin Holt's fiercest competitor, became the first chairman of the merged company. He acknowledged later that the merger might never have happened without the Caterpillar name. It was too valuable, too well known, too connected to the machines that had proven themselves on farms, in deserts, and in war zones. The company consolidated its product lines. Only 5 track-type tractors remained after the merger: the 2-ton, 5-ton, and 10-ton from Holt's old product line, the Caterpillar 30 and Caterpillar 60 from Best's former lineup. The duplications were eliminated. The legal fighting stopped. The resources that had been wasted in courtrooms now went into engineering and manufacturing. Sales the first year were $13 million. By 1929, sales had climbed to $52.8 million. Caterpillar grew straight through the Great Depression, while other companies failed around it. They developed diesel engines in 1931 that would help establish the diesel as the standard power source for heavy-duty vehicles. They painted their machines highway yellow to increase visibility on construction sites. During World War II, Caterpillar equipment served with the Seabees, the construction battalions of the United States Navy that built airfields and facilities across the Pacific Theater. The company ranked 44th among all American corporations in the value of wartime military production contracts. And all of it traces back to that Thanksgiving Day in 1904, to a peat field outside Stockton, to a man who refused to accept that his machines kept sinking. Benjamin Holt didn't invent the concept of the continuous track. That idea had been around for centuries. Over 100 patents for crawler-type tractors had been issued before his. But those machines didn't work. They existed only on paper, or as prototypes that fell apart in real conditions. The English companies he visited in 1903 couldn't make their tracks survive actual field use. The sophisticated designs failed. The elegant theories collapsed. Holt succeeded where they failed because he wasn't trying to create something theoretically perfect. He was trying to solve a specific problem with the tools and materials he had available. The peat soil of the Sacramento-San Joaquin Delta demanded a solution. His customers needed to work that land, and Benjamin Holt was stubborn enough to keep trying until he found an answer. That first test on November 24, 1904, lasted only a few hours. The machine was crude by any engineering standard. Wooden slats bolted to chains, no sophisticated metallurgy, no elegant design. Just brute force problem solving applied to an impossible situation. But it worked. Today, the company Benjamin Holt helped create is worth billions. Caterpillar Inc. operates in 192 countries. Their equipment builds roads, digs mines, clears forests, and moves earth on every continent. The distinctive yellow paint has become a global symbol of heavy machinery. The Hagen Museum in Stockton, California, houses the Holt Memorial Hall, dedicated to Benjamin Holt's contributions to mechanized agriculture. On display is a restored 1918 Holt 75 Caterpillar track-type tractor, one of the machines that served in World War I. If you ever visit, stand in front of that machine. Look at the tracks. Think about the weight of it, the power of it, the crude engineering that somehow worked when over 100 more sophisticated designs failed. Think about the peat fields that swallowed everything else. Think about the armies that mired themselves in mud for 4 years, until machines like this helped break the stalemate. And think about the photographer who watched this impossible machine crawl across impossible ground and said, without knowing he was naming a dynasty, "If that don't look like a monster caterpillar." They laughed at the caterpillar. Competitors dismissed it as a novelty. Military planners ignored it until the trenches forced them to reconsider. Traditional thinkers in every industry said wheels were good enough. Then the caterpillar won a war, built a city's water supply, reclaimed land that had been considered impossible to farm. The machines that rule construction sites today, that move mountains and reshape continents, they're all descendants of number 77, that ugly, improbable contraption that Benjamin Holt wheeled to the edge of Mormon Slough on Thanksgiving Day, 1904. Progress always looks strange before it looks obvious. The people who change the world are rarely the ones with the most elegant theories. They're the ones who refuse to stop until the machine works. The ones who rip the wheels off a perfectly good tractor and bolt on something nobody's ever tried before. Benjamin Holt died 4 years before his company merged with its rival. He never saw the Caterpillar Tractor Company. He never saw the empire that would bear the name a photographer gave his invention. But every Caterpillar that rolls off an assembly line today, every tracked machine that crosses ground too soft for wheels, every piece of equipment painted that distinctive highway yellow, carries a debt to the man who wouldn't accept sinking. The San Joaquin Valley still has some of the richest farmland in America. Parts of the Sacramento-San Joaquin Delta have sunk more than 20 feet below sea level since the peat started oxidizing, since the microbes began eating the organic matter that once made the soil so valuable. The very ground that inspired Benjamin Holt is slowly disappearing. But the machine he invented endures. If you want to see how another inventor solved an impossible problem, click the video on screen right now. And if you made it to the end, subscribe. The stories don't stop here.